Are we living in a black hole? A surprising observation by the James Webb Telescope is currently causing a stir. Researchers at Kansas State University have published a new study showing that there are structures out there that actually support the theory that our universe is located inside a bizarre gravitational monster. But what exactly did Webb detect in the depths of space? And how is it even possible? After all, black holes are known for irretrievably destroying everything and everyone and plunging their entire surroundings into utter chaos. Or are they? Well, not necessarily. So, be sure to stay tuned until the end if you want to know whether you're watching our video from the heart of a colossal mass monster. In the beginning, there was nothing. Because if we turn back the wheel of time by about 13.8 billion years, we end up in a difficult-to-grasp era in which the universe exploded into existence in a fraction of a second, thus laying the foundation for literally everything. According to the prevailing theory, all matter and radiation in the cosmos were concentrated in a tiny point during the Big Bang. This original singularity then expanded explosively, creating space-time, the fundamental forces of physics and all matter. And although the Big Bang Theory has long been part of the basic knowledge of cosmology, we must not forget that it's still a relatively young idea. After all, the idea of the Big Bang only entered the astronomical arena in 1931. At that time, Belgian priest and physicist Georges Lemaitre, based on Edwin Hubble's revolutionary findings, came to the conclusion that the cosmos is not only expanding, but conversely must also have been much smaller at one time. This line of thinking led to the conclusion that the universe could once have been concentrated in a tiny point and virtually burst out of a cosmic primordial germ. However, Lemaitre's groundbreaking assumption was not met with unanimous applause among long-established experts. On the contrary, a certain Albert Einstein is said to have told him that his understanding of physics was, quote, terrible. Lemaitre's former teacher at the University of Cambridge even described the idea that there had been a beginning of everything as repulsive. The bottom line was that the idea of a rigid, eternally existing universe was still too deeply ingrained in the minds of the creme de la creme of physics. And before Hubble proved that there were other galaxies out there that were even moving away from us, the Milky Way was considered the only galaxy in the entire cosmos. Some critics of the Big Bang even resisted the astronomical upheaval so vehemently that they attempted to reconcile the new findings with the old worldview and consequently put forward alternative theories. These included in particular the steady-state model of British physicist Fred Hoyle, which in the usual manner assumed an eternal, infinite, and largely unchanging universe. To compensate for Hubble's observation of the expansion of the universe, the model referred to a mysterious unknown field from which new matter is constantly emerging in space. Ultimately, however, the steady-state model did not stand up to real observations in space. In the 1960s, scientists realized that radio galaxies and quasars can only be found in the distant universe and not in the cosmic neighborhood of the Milky Way. This suggests that these phenomena only occur in very old star clusters. However, if the cosmos is unchanging, this type of active radio source should occur with the same frequency everywhere, and not only in the most distant and therefore oldest regions of the universe. The final nail in the coffin for the steady-state model was the discovery of cosmic background radiation. This is a relic from the early days of the cosmos and is still considered outstanding evidence for the Big Bang theory. Looking back, it seems almost ironic that it was Fred Hoyle who gave this theory its name. In a radio interview in 1949, the creator of the steady-state model described Lemaitre's idea as a hypothesis that all matter in the universe was created in a Big Bang, and made it quite clear that he did not think much of this assumption. Despite all this, the term Big Bang was so memorable that it stuck and nothing has changed since then. The problems with the Big Bang. The Big Bang is now practically sacrosanct among conservative researchers, even though it's still surrounded by huge question marks. And these are sometimes of a very fundamental nature. What actually caused something to suddenly emerge from nothing 13.8 billion years ago? How can something emerge from nothing, and what actually came before? Well, many renowned experts are convinced that there was simply no such thing as before. Stephen Hawking, for example, was quoted as saying, "The question of what was before the Big Bang is just as meaningless as asking what is north of the North Pole." Because time itself only began with the Big Bang, this is an event that cannot have been caused by anything or anyone. The laws of nature themselves tell us that the universe could have come into existence without any energy or cause. In other words, the exact origins of the Big Bang are far beyond our human imagination. But not all scientists are satisfied with this explanation. And as mentioned at the beginning, some researchers believe that the key to astronomical knowledge lies hidden inside a black hole. But more on that in a moment. First, let's briefly recall that more and more physicists have recently come to believe that our universe is not the only one. Instead, we may be just a tiny link in a larger multiverse, and there may be more worlds out there than we can even imagine. How and whether these worlds are connected is also hotly debated in alternative physics circles. What is certain, however, is that even in this scenario, the individual universes must have come into being in some way. But how? Well, it's worth listening to the thoughts of Nikodem Popławski from the University of New Haven, because for him there is no doubt that our universe was born in the heart of a black hole. Are we living in a black hole? What the James Webb Telescope has discovered. According to this theory, matter swallowed by a black hole would eventually reach a point where it could not be compressed any further. And although this primordial seed may be incredibly tiny, it weighs several billion times the mass of the Sun. Since black holes rotate at nearly the speed of light, enormous torsional forces act on the seed. As a result, it's not only compressed, but also twisted in on itself, just like a joke snake waiting to spring out of a can. Ultimately, the seed in the black hole could literally burst open, paving the way for the creation of a new cosmos. However, we would then be dealing with a cosmic gateway that can only be passed through from one side. But if someone were to fall into a black hole in the Milky Way, it is conceivable that they, or rather what is left of them, would emerge in another universe. Our own universe could therefore be the result of another previous cosmos. While the seed of this mother universe grew inside a black hole, it burst open 13.8 billion years ago and has been expanding ever since. Which means nothing other than that we may still be hiding behind the event horizon of a black hole. Now this all sounds pretty exciting, but somehow also very theoretical. The crucial question is whether there is any concrete evidence for this spectacular idea. And the surprising answer is that the James Webb Telescope recently observed something that could actually support this incredible theory. But what does that mean? Well, to understand this, we need to take a look at a study by a research team at Kansas State University. Led by Leo Chimay, the experts examined 263 early galaxies in the so-called Jades field, which Webb had previously analyzed. Ultimately, the experts were confronted with a pattern that was as unexpected as it was puzzling. Most of the galaxies observed rotate in the same direction. In other words, while about 2/3 of the structures rotate clockwise, only 1/3 rotate in the opposite direction. But why does this galactic movement pattern suggest that we are inside a black hole? Well, quite simply, because it starkly contradicts our fundamental expectations. After all, in a random universe, one would expect the rotational directions of galaxies to be evenly distributed. The bottom line is that there are now two ways to approach Webb's surprising discovery. The first, less exciting explanation is based on the assumption that we are simply dealing with measurement errors. More specifically, the so-called Doppler effect could cause galaxies moving toward us to appear brighter than those moving away from us. This could lead to a distortion in the measurements, making more galaxies appear to be visible in a certain direction of rotation than are actually present. But the second approach, and this is the astonishing part, says that our cosmos was created in a black hole that already had its own rotation. This idea is consistent with the so-called Schwarzschild cosmology, which postulates that our universe embodies the interior of a black hole in a larger mother universe. In this context, each black hole would represent the passage to its own baby universe, while the rotation of the original black hole would influence the preferred direction of rotation of the galaxies in the newly born universe. This starting point naturally plays into Nikodem's hands, which is why he classifies the James Webb Telescope's observation as follows. Quote, a preferred axis in our universe inherited from the black hole's axis of rotation could have influenced the rotational dynamics of galaxies and caused the observed asymmetry between clockwise and counterclockwise rotation. And your click could even result in a brand new subscription. Just press the thumbs up and subscribe to never miss another video from us again. We'll see you soon.